right, hello everybody. My name is Josh Baer. Today I'm going to talk to you about moving to the cloud. So Spotify's story of how we move from a totally on-premise infrastructure to the Google Cloud platform. First up, I want to talk about a bit of who I am, why I'm up here speaking. I'm a technical product owner at Spotify. I heard that's similar to at Criteo, a role called an EPM. Basically what it means is I used to be a person that did engineering work. I used to be someone that could code, now I don't. I spend most of my time in meetings. But I lead a team that manages a lot of the data infrastructure that we work on in Spotify. And I'm currently managing our process of our data migration to the cloud. And I'll be talking about that in a second. Oh, sorry, I just lost. Cool. Yeah, so I previously was building out Spotify's 2,500 plus Hadoop cluster. Also our stream processing and real-time capabilities. So if you want to talk about that with me later, I'm glad to have that conversation. But today I'm going to talk to you about Spotify's experience of moving to the cloud. And now this is an effort that we actually started around 2014 and fully committed to around the beginning of last year. By moving to the cloud, I mean, of course, the act of giving up our ambition of being in the hardware business for all our compute, storage, and processing needs. By moving to the cloud, I mean putting the ultimate faith in a third-party company to supply the fundamentals that we need to power our Spotify music playing service. It's a huge bet that a company can make, one where it's no longer fully possible to be accountable for the experiences that your end users are experiencing. And that puts you in a pretty vulnerable spot. And I'm going to start off this talk by saying that we're not actually, by talking about the present, how many people in this room are familiar with this diagram? Yeah, probably anybody that's been to a business or technology course or been in a presentation by anybody that's been in a business or technology course. So this model expresses how adoption goes in organizations. Starts at the far left with the people that are early innovators, goes on to the early adopters, the people are really eager to learn from what the innovators have gone, then moves down the line to the laggards, the people that are kind of stuck in their ways, but have finally have to realize they need to adopt. And this can also be used to talk about our cloud migration at Spotify. And I want to make it clear that we're not right now 100% on the cloud at Spotify. We're actually not even halfway there. So we've been working on this since 2014, and I think we're somewhere here. We're somewhere about a third of the line where we've got the innovators and the early adopters fully on the cloud, but we're working on that early majority. So that's 3 years that we've been working on this, and we're not halfway there. And I'm going to talk to you today about some of the challenges that we encountered in those 3 years so far. Now first, I'm going to back up. Hopefully by now everybody knows what Spotify is. You know, when I first started talking maybe 3 or 4 years ago, this was a super relevant set of slides, but now hopefully it's not so much anymore. So Spotify is a music streaming service. It was launched in 2008. It's got 2 tiers, a premium tier and a free tier, and it's available in over 60 countries. We have over 100 million monthly active users. They play from a catalog of over 30 million songs. I got to click, I don't want to click. And they combine for over 1 billion plays per day. And we have a lot of data. In fact, we often used to say that we were the biggest Hadoop cluster in Europe. And we were able to say that because nobody was really casting any doubt on that. Nobody went up and said they were the biggest Hadoop cluster. We believe there were bigger Hadoop clusters, especially in the governmental industries and, of course, the banking and stuff, but they never really talked about it because that would be creepy. In fact, there's only one other company that's ever said that they have a bigger Hadoop cluster than us. And that's actually Criteo. And we've gone back and forth about this. You can say, oh, we have more machines. You know, maybe that's the way you want to gauge it. We could say, oh, we have heavier machines. We have more disk space usage. There's a lot of ways to say it. But today, I'm going to announce a winner in the biggest Hadoop cluster in Europe. And that's that Criteo is the biggest Hadoop cluster. And the reason for that is because last year we bought the last machines that we'll ever buy for our Hadoop cluster. And they're installed in our data centers. It's never going to get any bigger than that. And that's because we're transitioning all that workload to the cloud. But we did have a pretty big Hadoop cluster. It was about 2,500 nodes. We had about 50,000 cores and 100 petabytes of capacity. So that's still quite a bit of data workload that we're talking about. And that's brought a lot of the challenges that I'm going to talk about today. So I'm going to go back really quickly through the history of Spotify, just so you have some context of where we were. 2007 to 2011 was the beginning, 2008, 2007, when Spotify was almost completely bare metal. We grew our bare metal presence by doing these things called pods, which were independent failure domains. So if a pod went down in a particular data center, you could shift all the users that were connected to that pod to another pod and not affect the end user experience. So we were growing like that. We had about 2 data centers until 2012 when we launched in the US. And then we started to have a little bit of issues trying to keep up with our compute needs. So we thought that maybe we should try out this cloud thing. And in 2012, we started to move our data processing workload in particular to AWS, specifically to EMR, Amazon's Elastic MapReduce. Unfortunately, at the time, we found that there were some issues with stability. We were running jobs that weren't completing as they were on our on-premise data center. And they were also pretty considerable costs at the time. And when you added up the considerable costs with the stability, and this again was in 2012, things are not necessarily the same today, nobody really wanted to move to the cloud. And that was a big problem for us, because if we had the theory that we want to transition our excess workload to the cloud, specifically for the data processing, and then nobody wants to move, it's pretty hard to get everybody over. So in 2012, we decided that our early cloud experiment was over. We ordered 700 machines for our Hadoop cluster, and we decided to open up 2 additional data centers, mostly to serve our US users and the rest of the Americas, because we were also expanding into South America and Mexico and some of the other countries. But despite all our failures, we did see an advantage with Amazon's cloud, and decided to keep some of that cloud capacity for excess storage, specifically for like hack projects or experiments. It was really easy to just spin up some instances, do some work, keep them running for a little while versus having to actually buy physical machines or make sure you're using those physical machines. But despite all that, despite deciding to stay in our data centers, growth of Spotify users actually remained rapid, and we started to fill up the capacity in our 4 existing data centers. So around 2014, we were faced with another decision. So we're filling up our data centers. We need additional data centers. Probably doubling the set of our data centers means that we actually have to put a huge investment in our data center expansion team and get more in the hardware business. So we decided to try out the cloud thing again. And this time we wanted to try out the Google Cloud. So why move to the cloud? There are 2 main reasons. The first is that cloud providers have matured, decreasing costs, increasing reliability, and a variety of service offers. So when we first started out using Amazon Cloud in 2012, it was mainly just Baer compute instances that we were looking at, also with the EMR. Now cloud providers have just so many services built on top of them, and they're known for their reliability, which is great. The second one, and probably the most important for Spotify's use case, is that owning and operating physical machines is not a competitive advantage for Spotify. The team that wins the music streaming business is not going to have the best hardware. That's not a key differentiator. The people that win the music streaming businesses are going to have the best data, the best recommendations, the best components built on top of the music streaming experience. And that's really what we wanted to focus, and not focus on maintaining our own hardware. So another aspect of this you might wonder is why did we move to Google's cloud? And that's that we were looking at the various cloud providers and we saw a distinct advantage with Google. So we always saw that Google is 5 to 10 years ahead of everybody when it comes to data processing. It's something that we probably all know being in the data business. Open source projects are usually come out of papers, white papers that Google produced or other people like Google produced. So jumping on that cloud, the source of that technology and innovation was going to be an advantage for us because we could jump directly onto that stuff a little bit before the open source community. So it's that easy, right? We decided to go to the cloud, go to Google Cloud. All we have to do is move all our workloads to the cloud. Except we have to do that without disturbing the business, without losing data. While learning to use a bunch of new tools. And by the way, we're probably Google's first ever big customer that's made this shift from totally on-premise to the cloud. And that sets up the series of challenges that I'm going to talk about right now. So the first challenge I'm going to talk about is the building blocks. So we had a bunch of new types of tools that we could use with Google Cloud. And learning that was the first challenge. So it's said another way, what tools can we take advantage of Google's ecosystem? The first one I'm going to talk about is Bigquery. Who in this room has heard of Bigquery? All right, a fair amount. So Bigquery is an ad hoc, interactive, hosted querying service for massive data sets. It's a very similar use case to Hive if you use that, or Presto if you use that. But since it's managed, there's no need to worry about setting up the Hadoop infrastructures or operating the physical servers. It leverages most of Google's internal tech, including Dremel for its query execution, Colossus for its distributed storage, Borg for distributed compute, and Jupyter, which is Google's amazing network technology. So to give us all of an idea of performance, I thought I'd do a quick comparison. So I knew coming out to France, I was coming out to France last week, but I actually realized I didn't know a lot about like French music preference. So I wanted to come up with a simple query. Who are the top 10 artists by popularity in France during all of last month? So this was actually written on the 28th of May, so it takes into account up to the 28th. So this is two queries almost exactly the same that were written in Hive and Bigquery. Now we'll say at the bottom, our Hive version that we used is 0.14. This was not totally optimized. We're not using columnar storage, but it gives you an idea of the typical experience of our analysts using Hive versus Bigquery. So the first one took over an hour to run, and it processed over 21 terabytes of data. On Bigquery, it finished in just about a minute, and it only processed 2 terabytes of data. So this is just a sample of the type of experiences that our analysts have using Bigquery versus using Hive. Oh, by the way, here's the answers. Yeah. So to be honest, I only recognize one of those names, and that's down here, number 7, the redhead from the British Islands. So it seems like one of the most popular playlists on Spotify is called Punch Leaners. I don't know if I'm pronouncing that right, but it's like French hip hop. That's super popular, I guess, on Spotify in French. I don't know if that's, yeah. So because of results like this, Bigquery really took over the ad hoc querying use case immediately. The biggest blocker was actually to have all the data available. An amazing thing that we learned through this process is as you're able to get answers quicker, your pace of learning increases and the amount of questions that you can ask in a particular day just becomes more and more. And you can ask more advanced questions and get to places where you never thought you could be when it took you, an hour to run a query. I mean, the difference between using Bigquery and Hive is with Hive, you'd start running a query, you'd go to lunch, you'd do something else, then maybe you'd come back and get your results, and by that time your mind's in a totally different state, you're thinking about something else, and you're kind of done for the day. But with Bigquery, you can get really quick results, and then iterate to produce some real insights, and it's pretty powerful that way. And BigQuery is very powerful. It changed the way that data scientists and analysts answered questions, but our transition to BigQuery wasn't without problems. In order to process data on BigQuery, we still needed to get our data from our data center to BigQuery. So our first attempt to do that was a tool that streams Avro records. We use Avro as a storage format on our Hadoop infrastructure. We decided to stream records from Avro into BigQuery. The problem with that is that this used our limited VPN. So we have already a limited bandwidth between Spotify's network and Google's network. And a subset of that network is connected via our VPN. So it's kind of like in our internal network. But that actually shared the same capacity that some of our services to play music back and forth. So we migrated some of our services over to the Google Cloud, and they need to talk to our on-premise systems in order to get information. That was affecting the ability with these data transfers for BigQuery to do that. So we quickly realized that that wasn't going to work. Our second phase was that we could actually split it up into a few different things. So we could copy data into GCS, which is Google's cloud storage solution, similar to Amazon's S3, using diffCP. And diffCP uses HTTPS, so we don't have to have that in our VPN. And it exposes a wider swath of network bandwidth available for us. And once we have it already into the Google infrastructure, then we can use Google's own tool, which is just called a loader, that loads data into BigQuery itself. But that did still come with challenges. So the first challenge is that copy jobs can stress the network still. Although we have a pretty big pipe between us and Google, it's not an unlimited pipe. And when you have like an outage, or you have a big incident with a big data set, that blocks data for 24 hours or maybe a little bit beyond, trying to catch up can easily saturate that network link and leave you in a situation where you have both high priority and low priority jobs that are coming at basically the same rate, which is a problem because your high priority stuff needs to get there as soon as possible. So that's the first issue with the bandwidth between us and the data centers. The second one is one that we've dealt with a lot on our transition to the Google Cloud, and that's this quota system. So the cloud providers all have quotas. They're both to prevent costs from skyrocketing on a consumer's aspect and to prevent them on the cloud side from people using way too much capacity. And BigQuery Loader also has a quota system in place, and we've occasionally hit that quota, so we're actually not able to copy to load data quick as we want to into BigQuery. So that's BigQuery. The second tool that I'm going to talk about is Cloud PubSub. Now, similar to the first question, who here has heard of Google's Cloud PubSub? Okay, a little bit less. So Cloud PubSub is at least once globally distributed message queue. It's for high volume, low topic, publish, subscribe behavior. So this isn't the kind of thing where you want millions and millions of topics. It's something where you really want high throughput. It's very similar to Kafka, but without needing to operate servers and supporting infrastructure. So similar to Criteo, we were really big into Kafka at Spotify. Kafka is something that was working for the most part really well for us, but when it went bad, it went really bad. And dealing with those issues, specifically like trying to get information over the ocean into our London data center, which is where our Hadoop cluster we had to spend a lot of engineering hours on that. So we transitioned to the Cloud PubSub environment, and we were able to take our workload, which is around 800,000 events per second, over to Cloud PubSub without any problem. We were pretty amazed by it. And even better, on my previous team that I worked on, which is this real-time streaming team, we saw P99 latencies of ingestions about 500 milliseconds. I would say our best case solution with our Kafka infrastructure, because we were shipping data from all over the world to London, was on the order of 30 seconds. Worst case, it was in the order of minutes. That has a lot to do with the Kafka version that we were using, which was Kafka 0.7, and we had to build some framework on top of that to get guaranteed delivery. That's a whole nother topic. But best case 30 seconds down to best case, or to worst case 500 milliseconds is really transformative and open up so many cool real-time use cases for us. Yeah, and then ingestion from globally distributed non-GCP data centers is painless. So we're distributing our users all over the world right now, shipping data, as I mentioned, all the way from around the world to London. Has all kinds of issues, like when a shark bites into a cable, takes out a lot of capacity across the Atlantic, like you have to deal with that stuff. Now we're just relying on Google for taking care of all that, and Google's ability to take care of that is a lot better. But it didn't come totally without its problems. I will say that of all the Google infrastructure that we use, Cloud Pub Sub is one of my favorites because it took such a big pain point from us and made it a little bit less easier. But the one challenge was that because we were able to move our raw event delivery over to Google so quick, we were actually moved it before all the people that moved their pipelines over. So we had the data being delivered into Google, and then we actually had to copy it back over to our on-premise data center so people could access it and process it. So it was like the reverse challenge of the previous one. We were saturating this network bandwidth back to our Spotify data center. Now that's actually a little bit easier of a problem because we can control that. Whereas the other way, it's a little bit, we have autonomous teams all over the world that can copy data to Google. It's really only our data infrastructure teams that are copying data back onto our on-premise data center. So it's a little bit more predictable, a little bit easier to control. So the third tool that I'm going to talk about is Google Cloud Dataflow. So final time I'll ask how many people have heard of Cloud Dataflow? Okay, about half. So Dataflow is a managed service for running batch and streaming jobs. It's inspired by internal Google tools like Flume Java and Mailwheel. And the programming model is open source as Apache Beam. And oh yeah, it's a unified API for batch and streaming. So we have two distinct use cases for Dataflow at Spotify. The first is the batch use case, and that's at Spotify. We actually wrap it in a tool called Shio, which Rafal talked about last year. It's a tool that we developed in-house at Spotify, Scala API on top of Cloud Dataflow, and integrates with BigQuery really great. Almost all new data processing is written with Shio at Spotify. So it's really taking us from a MapReduce shop, where we were doing a lot of, way back when, Python streaming. We moved on to Apache Crunch. We did a lot of scalding. Now we're almost exclusively doing Shio on top of Dataflow, in addition to using BigQuery for pipelines. So that's a batch use case. We also were able to use it for the streaming use case. Cloud Dataflow is a exactly once stream processing framework, so you can think of it as a similar replacement for Spark or Flink streaming. Or at Spotify, we had a lot of Storm workloads that we've transitioned over to Cloud Dataflow in streaming mode. So it optimizes for consistency, which can complicate real-time workloads. That's really, you have to think it's exactly once. It expects to have a consistency, so in your code, you actually have to sometimes account for errors if you want to be able to constantly be doing real-time processing. So that's had a bit of challenges. As I mentioned early on, we were one of the first big Google customers to do the transition to Google Cloud. We were probably the first big customer to ever really use Cloud Dataflow. Internally, Google has been using these tools, Mailwheel and Flume Java, for a very long time. But it was the first time they bundled those tools together and exposed it as a cloud tool with Dataflow. And at Google, people were using the raw components, except for the teams that they acquired. And those companies that they acquired weren't quite the size of Spotify. So we ran into a lot of stability issues, especially in 2014 and the beginning of 2015, particularly in the streaming mode. There were probably around this time last year, I would have told you we couldn't keep a streaming job up and running for more than a week without it failing for some weird reason. Now that's fortunately not the use case. But we've also run into situations where we ran into a bug, we filed a bug ticket with Google, and the engineers basically said to us something like, oh yeah, we thought someone would run into that, but we didn't think that anybody would run into it yet. So we've had some issues with that, being a little bit of Google's QA team with the Dataflow. But fortunately, it's actually a much, much more stable product. And you can all thank Spotify for that. The other cloud data flow challenge that we've seen is cloud is not an infinite resource. So the marketing material tends to make you think that it is. They'll say stuff like you never have to worry about capacity planning anymore, or just spin up all the compute capacity you want. We found pretty early on that that's not exactly the case. With these teams, and at Spotify, it's a little bit of the culture. We have a total autonomy between the teams, so anybody can just decide to spin up like 20,000 machines for their job, and they can do that without going through a lot of hoops. So that happened, and then we started running into instances where we'd have a particular zone that ran into an outage of a particular resource, like compute or I don't know, SSDs or PDs or something like that. So that was an interesting learning experience. It's something that we're actively in conversation with Google to improve. And we do believe that situation is getting a lot better. They believe in the theory of law of big numbers. So if you have, they're meant to have enough capacity for users that spike. And they have a theory that over time, these spikes will essentially even out. If these spikes for a lot of users happen at the same time, then they're in a bit of a bad situation, and that's what we hit so far. And the other problem with that is there's no guaranteed capacity for critical jobs. So if you have a limited amount of capacity, you want these business critical jobs to always finish no matter what, even if there's only 1,000 machines or 1,000 instances available, you want those jobs to finish and be prioritized over something like a backfill that goes back to 2014. Right now, they don't have that ability, and that's something that we're really pushing for. So that's been a bit of a challenge. And so to put things in perspective, here's a bit about how those technologies have been adopted at Spotify. So almost instantly, we started to see Bigquery take over the Hive use case. A little bit after that, we had Cloud Pub Sub totally replace our Kafka infrastructure. Last year, the batch use case was started to take off with all new jobs being written in Shio. And then towards the end of last year, we were actually able to take our Storm jobs and start rewriting them to Cloud Dataflow streaming mode because it does have this stability and it offers the managed aspect. So we don't have to worry about our Storm infrastructure anymore. So that's the first set of challenges is figuring out the tools. The second set of challenges were the paths. So how do we move all our pipelines and workflows to GCP? That's the challenge that we're looking for. And what set of paths can start without this poem from Robert Frost? It's super popular in the US. Anybody that's been through an English class has probably heard it. Two roads diverged in woods, and I took the one less traveled by, and that's made all the difference. So the question that we pose to each and every team that owns data pipelines is which path are you going to take? And we offer two pathways. The first one is called the Forklifting Path. That's to take your data processing pipelines and moving them over to GCP without re-architecting them. So this is also known as the lift and shift, the idea that you really don't do a lot of work, you just move your stuff over to the cloud. So the Forklifting Path. Previously at Spotify, we launched all our jobs from team-owned machines called edge nodes. And these edge nodes were very custom, set up with their own packages. Now we wanted to launch containerized jobs via distributed cron. And we decided to have this as part of our Forklifting Path. And this has been a bit of a challenge. Now, as I'll say later on, I think the biggest thing we learned is that if you're transitioning your stuff to the cloud, you want to keep this path as simple as possible. It's really easy to fall into the trap of trying to get rid of a lot of technical debt, and that's what we did here. We ended up building a lot of new tools. So one tool that we built is called Stix. Stix is a data processing schedule for Kubernetes. It's kind of like a distributed cron. It just runs it runs scheduled Dockerized containers. It's pretty cool, but then you have to Dockerize your whole pipeline and be able to schedule it. The second tool we built is called Spydra. So Google has this tool called Dataproc. It's Hadoop cluster as a service. What Spydra does is it abstracts a little bit of the low-level worrying about spinning up the cluster, what the settings are, and all that. It also allows you to do a few things. So one is you can spin up a cluster just for a single job. The second one is you can point a job at a pre-existing cluster. So that could either be a cloud that's spun up on Google's cloud, or I'm sorry, a cluster that's spun up on Google's cloud, or it could be on our on-premise infrastructure. And that's been open sourced, and there's a link down there. So as I mentioned, that was a bit of a problem. We have to totally rewrite our jobs to be able to use these things now. So our forklifting path is not such a forklifting path. You don't have to change a lot of the code, but you do in each and every pipeline you have to make some changes. And in the next section I'll talk about why that's complicated. So the other pathway is the rewrite pathway. And that's if you have the capacity in your team, you can actually rewrite your job using either Bigquery, if you can express your job logic in SQL, or you can write it in Shio, which is Dataflow. So that uses the latest and greatest, but requires a much, much larger time investment. And the reason why is it's very simple. I've had a lot of discussions with teams that want to rewrite their pipelines because they look at their stuff and they're like, oh yeah, we'll just rewrite that. But what almost always happens is they don't just rewrite it, they end up re-architecting too. Because whenever you look at code that even if you wrote it 3 years ago, you look at it and you say, oh, this is crap. I'm just totally going to do this. And it goes from a week-long rewriting process into a month-long re-architecting process. And the other issue with this too is that we've seen jobs that take 5% of our on-premise Hadoop cluster transition to jobs that would take 20 to 30% of our on-premise Hadoop cluster because they totally re-architect. They kind of move themselves off our common set of ETL jobs that transition to it. So that's been an issue that we've seen with that path. Yeah, so those are the two pathways. The third one that I'll talk about, and I'm running slightly short on time, so I'll speed up a bit, is our dependency tree. So this challenge is how do we move our 2,000 plus unique jobs on GCP to GCP and the 20,000 plus unique endpoints produced every day. And this endpoint is the concept of a data set, like an instance of a data set. So for a particular day, you have an endpoint. So this is what Spotify's dependency tree looks like. I don't know if you have something similar to this in Criteo.
Not at all. It's much cleaner.
Much cleaner. Yeah, and this is probably a little bit of a simplified version. If I printed this out in order to see the individual job names, we haven't figured out the size of paper that we need to make it legible. And moving a job is like taking a branch from a tree and leaving the leaves in place. This is a bit of the challenge moving to GCP. Sorry. You can't just take a job in the middle here if you're transitioning to GCP, because then everybody that's downstream from that, all of a sudden, they don't have any data to produce. So it's a pretty complicated process of moving a job to GCP. So here's actually another view of our dependency graph. This one takes away some of, it optimizes a little bit more for the artistic. It takes away the common set of raw event delivery. But I'm going to use this to drill down to a very specific pipeline. This is over here in the corner. So you can think of this as like an isolated team that has a common set of dependencies and produce a set of outputs. So moving a team to GCP, what you want to do, you isolate the team's jobs, you create a copy of the job on output on GCS, and you have to do a job-by-job copy to the cloud. This is a little bit about how that looks like. So you have the data that's being produced right here. You just take this, you copy it straight over to GCP, and then all of a sudden you have to rewrite the jobs or move the jobs, and then at the end you get rid of your original jobs. So that's the process of migrating your pipeline over to GCP. But now you have to do that process over and over and over again. And that's really the challenge that we're faced with at Spotify right now. One, we have over 100 teams that have data processing pipelines. So managing that complex set of dependencies, trying to coordinate that so we move everything over successfully is quite a challenge. So those are some of the challenges. The biggest challenge that are facing us, of course, there is others that I won't have a lot of time to talk about right now. I'll just say 2 sentences about it. So first one, vendor lock-in. Of course, this is the first one that people talk about when you're moving to the cloud. It is an issue for Spotify. We're a bit defensive about which tools we use. So one tool in particular, like Google Cloud Spanner, it's super awesome. But right now we're trying to make it, we're trying to reduce the team's dependency on it unless they absolutely have a use case that needs it. Because it uses Google's amazing network technology that's probably not going to be replicated in the open source community anytime soon. So we're a little bit defensive about some of the tools that we use. But we're committed to the cloud. So for some things like Dataflow, we're not letting it block us. The other one, of course, is cost. The way that data processing translates into cloud is not necessarily a one-for-one cost basis. Right now, we're more optimizing for our speed and transitioning to the cloud. So this is not something that we're worrying about as like the first thing. We're trying to prevent abuses, of course. But it's something that's going to be more and more prevalent over time. The third thing is dealing with the black box. So as engineers at Spotify, we had this huge, almost existential problem when we started to move to Google Cloud, and that's that when you have errors, you can't necessarily fix them. Sometimes you're dependent on Google to fix the problems that you have. And that's a pretty frustrating experience when we used to be able to go dig down into the native code and fix our problems. So that's been a transition and something that we've had to learn about, and that's probably a whole another talk's worth of material there. So really quickly, the future. Those are some of the challenges we hit so far. So again, we're right here in our migration. We've had our innovators that have moved right away. We're done with the early adopters. The future is all about the teams that are hard to motivate, the teams with other competing priorities, moving them to the cloud. So this is a simple visualization of where we've moved in the last 3 months. So the big circles are business units at Spotify. This is just looking at the GCS to HDFS. It's kind of approximation of workloads that are running on the cloud versus workloads that are transitioned or are still running on premise. So if you can see on the left circle, there's a little bit more red. That means everything for some of these teams were running on premise. For the right side, you can see that there's no circle that's totally orange. A lot of times what that means is that they're actually having to copy data back to our on-premise infrastructure so that downstream consumers can do it. So for example, this one should actually be totally orange. We've been totally transitioned to the cloud for that. Okay, I'm out of time. Yeah, so right now what's going on is we're around the time where we've had 30% of our pipelines moved over to GCP. In the next quarter, we're going to have the bulk of our migration. We want to get over to 80% of our teams on GCP. So it's going to be a lot of work, a lot of dedicated work that goes into this. And of course, by the end of the year, we want to be 100% over. Yeah. So really quickly through the key takeaways, 5 quick lessons that we've learned. When moving to the cloud, keep your forklifting path as simple as possible. That's something that Spotify's absolutely failed at, and we're dealing with that. Every time we move a team over, we have to change a lot of pieces. And that means the migration process is taking a lot longer than we expected. So in the future, if you move to the cloud, try to keep that forklifting path as simple as possible, then do your optimizations afterwards. Second one is to visualize your progress. So that simple visualization wasn't super pretty, but it's very valuable for me being able to go to teams and being able to say, like, in the last 3 months, you said you were going to move to the cloud. You're actually still at the exact same point. These visualizations have been super helpful in understanding where we are in our transition and where we need to be. Third lesson is that cloud was not an infinite resource. It's something that you still have to worry about moving over to the cloud. You have to keep in your mind like capacity planning. It's the marketing materials may make you think that it's infinite resource and you don't have to worry about these things, but you actually still do. The good thing is that you're able to do some things like spin up a lot of capacity really quickly without having to worry about buying those machines. Fourth lesson, it hasn't been easy, but we still believe it's actually worth it. So despite these challenges that we have a lot of new capabilities that we've gotten without having to operate a lot of the infrastructure ourselves. And we believe in the future it's just going to get better with the cloud. So we're pretty happy. The fifth lesson, and this is something kind of our motto in data infrastructure at Spotify. It came, I think, when I was really jet-lagged and like mixing up words, but we say we're doomed to succeed. And that's that concept that the more successful we are in data infrastructure, the more people start to use our tools, the higher expectation they have for our tooling, and the more they start to complain. And the worse we feel about it because more people are complaining. So every time we succeed, we also have to deal with a lot of problems. And that's just, I guess, a general takeaway. And that's in the cloud, we've seen that too. So that's it. Of course, this is the one that I have to do for Spotify. We're always hiring. And thanks, NABDC and Critio for allowing me to do this talk. That's it. It's up to you.
We can do a quick round of questions for Josh if anybody has anything they'd like to hear. Okay.
Hello. What's the teams are saying about the migration? Are they happy to have finally something to work with, or they are more disturbed by that?
The teams that are working with the migration, are they happy?
The teams that are working on something else, on the features, on the business, you're pushing them to move their job on. Are they disturbed or happy to have a new technology?
So it's interesting. I was just at a meeting with all the product people at Spotify a few weeks ago. And one of the complaints that the product people had was that their teams, instead of focusing on building features, were focusing on like transitioning to cloud, because a lot of people are actually really eager to play out with these new. It's kind of like playing with new toys. So the teams that are using it in general are pretty happy. Of course, there's some people that are unhappy with if they're dealing with stability issues. I know the team that I worked with that did like real-time processing. There was quite a bit of frustration when we were. We'd have a job that was running for a week, and then all of a sudden it would die for some random reason, and we'd have to file support tickets, find out that it was a bug, and restart it again. So there definitely are cases where the teams are a little bit more frustrated that you don't control your own destiny. But I'd say by and large, like it's been pretty motivating for a lot of the engineers, and they're happy.
Okay, maybe time for one more.
What do you plan to do with your bare metal machines at the end of the migration?
Yeah, so that's a great question. That's actually something that we're looking into in the next 6 months. I don't know specifically. There's a bunch of different things from leasing them out to just destroying them to trying to resell them. I don't know. I'm not in those conversations. What I'd like to do, so. The team that I worked on for about 3 years at Spotify built our Hadoop infrastructure. I think I joined when it was about 60 or 200 nodes. We built it up to 2,500 nodes. I'd love to be able to say, like, we're shutting down our Hadoop cluster, turn off the lights, go in there with like a bottle of whiskey and a sledgehammer and just like go to town. I'm pretty sure they won't let me do that, but I really don't know what they're doing. A lot of the machines that we have are like at a end of life. So they'll probably just get rid of it, but I'm sure there are some machines that they, you want to buy a server? Yeah. All right. Well, thanks very much. And I'll be around for lunch if there are any follow-up questions.
Thanks, Josh. Funny question there. Wait, one thing. Funny question or funny story. That actually used to be an interview question at Criteo. One of our sort of founding directors of machine learning at Criteo actually used to ask that. That was his pet question. I give you 10,000 machines. What are you going to do with it? And then we. So I think he would have failed that one, but it's all right. Okay, so I'd like to welcome Nicolas to the stage. He's going to introduce himself and talk about some pretty cool visualization stuff that they're doing at Uber.